And today we will start our first lecture from the discipline Constructions of Buildings and Structures, part 4. What questions we will consider during our course? So, first of all, we have to understand that this discipline is very necessary for the future architects, and why is that so? It is caused by the first question, because it is generalization of knowledge in special disciplines. All technical disciplines that you have considered previously, like strength of materials, structural mechanics, reinforced concrete, metal structures, and constructions of buildings and structures, parts 1 from first till third. All those disciplines are generalized in my course, because in my course we will consider some questions which you have already studied previously, but in my discipline, all those structural schemes and structural systems that you have considered previously will be connected with real structural elements, and I will explain you how to develop structural system of your future building, of your uh, course project, or your diploma project, how to develop your diploma and course project, including structural elements. So, by the way, you will, I think, like an architect, you will take part in various contests, architectural contests, and it is very important to prepare structural part when you developing something for the contest. So, first of all, one more time, which is the generalization of knowledge in special disciplines that you have considered previously. Next, it is completely for 100% related to the profession, and I will explain you why. Because according to my discipline, after this course, you will be able to prepare the explanatory note to your design for your diploma paper, for your future projects, because the template of regular explanatory note for the project, which is connected with the structural part, is considered completely in my course. We will start from structural schemes, structural systems, and we will finish with reconstruction and difficult ground conditions like karsts, landslides, etc. So, and in your future explanatory notes, you will be able to consider and to classify which kind of karst or landslide or undermined territory you have on under your future building. So, it is 100% related to the profession, and it gives you a chance to work as an architect, as a real architect, not as a designer who creates interiors or exteriors of the building, but as an architect who can create complete building, who have an idea how to make something beautiful, something interesting, and something which can be built in in real life, in real world. Because some architectural ideas are so beautiful, so huge, so interesting, but they can be erected only on the moon, because some of those buildings are impossible to build to withstand the gravitation, because some interesting architectural ideas impossible because of even gravitation and the own weight of those structural elements. So, all our information will be divided in 3 modules, but as I told you previously, we will make, after section 1, we will make one first module work, Google tables, where you can make your quiz to answer the most correct, to give the most correct answer, to choose the most correct answer between the rest of the variants of the answers. So, first part, which we will start to consider today, is called construction solutions for residential, public, and industrial buildings. Next section, it is connected with the second model, will be difficult ground condition, and section 3 will be connected with the reconstruction. So, structural solutions for the reconstruction of buildings. So today we will start with the first section, which is called construction solution for residential, public, and industrial buildings. And what is a structural type? It's a system of vertical and horizontal and arbitrarily oriented elements which support the special stiffness and geometric stability of the building. So, and further, we will consider both of those terms: what is special stiffness and what is geometric stability. But if you will consider this picture, it's this is the design model of a real building. It's one of the Stikon's buildings. It has reinforced concrete structural scheme. You can see here columns, you can see here reinforced concrete slabs, and here you can see some kind of walls. And why those walls are not on the complete height of this building, and I will explain you why. It is caused by that these walls are not load bearing. They are not taking part in the overall structural work of the building. So that is why I have shown only part of those exterior walls, and it is one of the stages of erection of that building. So they are building first, onto the first place, they are making reinforced concrete elements, and after they are erecting exterior walls. So, and in this situation, in this structural scheme, I consider the situation where when they have erected vertical elements only for the part of the building, and the rest elements, non-load bearing elements, those exterior walls are erected only till 10th floor. I don't remember. In that situation, I was examining the impact of those non-load bearing elements on the overall structural behavior of the building. But in this case, if you will consider this whole building, so structural scheme of this building and structural elements are those reinforced concrete, not these AAC, aerated autoclaved concrete walls or masonry walls, but load-bearing elements. It is horizontal elements, roofs and floors, vertical elements, walls and columns, and somewhere there you can see the inclined elements, stairs. So, and structural type of building, it is system of vertical, horizontal, and arbitrarily oriented elements which support the special stiffness and geometric stability of the building. So, and this is the first definition that you have to know. And is it clear, or you need extra explanation about this question? Yeah, okay. So let's move further. And what kind of structural types do you know? So first, and the most ancient, the most well-known system called Mullion beam. It's Stikovo-Balkovый. Тобто Mullion beam structural type. Here, one of the oldest building which was erected according to this Mullion beam type, and you can see here vertical elements and horizontal elements, Mullion beam structural type. And here, and it was erected 300 and 600, 3,600 years before Christ. And uh, two, no, no, not two, but 5,600 years later, something like this was erected in Odessa, and as you can see, there are same elements. Yeah, those buildings are erected from various materials, but system and connection of the elements is the same. We can see here vertical elements, but in this case it made of limestone, and in this case it made of reinforced concrete. Those horizontal slabs made of limestone, and those horizontal elements made of reinforced concrete. So and you have to admit that during those all thousands of years, nothing had been changed except the materials. But the structural type mullion beams is the same: horizontal elements and vertical elements, and the connection between them can be solved by various kind of joints and connections. But vertical and horizontal elements. So that's called this that structural type called Mullion beam. Next, well-known structural type, as you can see, called vaulted arch. Vaulted arch. Арково, арковий він називається. Тобто, so you can find that this is natural structure that people started to use for their building. So it is a naturally created structural opening in the overall big structure. So, and this principle and this idea was used by architects, by ancient architects, to create something beautiful and something interesting. So this is the same idea, and this idea called vaulted arch structural type. And what preferences do we have, do we get using this structural type? So, for example, like 90 years ago, was built a huge monolithic dome with a diameter of 55 meters, and the thickness of the dome was only 7 centimeters, like this, 7 centimeters. So, for example, yeah, here it is, 7 centimeters. Yeah, and this dome, that dome covered a span of 55 meters. Can you imagine it? 55 meters. It is hard to run this distance, 55 meters. And in that case, it was covered by a reinforced concrete structural element with the thickness of only 7 centimeters. For example, if we have decided to if they have decided to cover the dome with such a span 55 meters, they will have to use so if they decide to make that building not in vaulted arch structural type but in mullion beam, in that case they had to use the slab or beam. No, in that case, it would be beams. Beam with the height of more than 5 meters. So to cover that span with the dome, they have used a 7 centimeters thick slab, but to cover it with beams and slabs, they had to use a beam with a height of more than 5 meters. So it's like 1.5 floor of regular building. So the height of that element. So that is why vaulted arch structural type is widespread. It is used for religious building in most cases, but not only for them. For various commercial buildings, that it is used also. So it was a second structural type which called vaulted arch. Do you have any question about vaulted arch? Is it clear, or you need the extra explanation? Thank you. And a final one. So there are only three structural types, and we have already considered two of them. So third structural type is called suspended. Suspended, it is the most contemporary method, because the oldest one is Malian beam, welded touch is not far from our time, and most modern, last and current century, it is suspended structural type. And this structural type is used only for the unique buildings. I don't know what Odessa building we have with such structural type. Oh, you know this building. Do you know Trade Center Panorama on the Tairova region? It's on the Koroleva Street. Yeah, so the roof of that building is was covered with such kind of structural scheme, with such kind of structural type. So first structural type we have already considered, and from the historical point of view, we know that the most suitable. So all of those structural types were developed for various materials. So, and Malian beam was initially developed for wooden and huge masonry blocks. Uh, and these systems has a huge history compared to the, for example, for the vaulted arched structural type. So the oldest is Malian beam. Next structural type called welded arched, and the most modern, as I told, is suspended. So if we will compare those all those structural types and their behavior and their interior forces, we will define next important moment. So, for example, if we will consider slabs, it's horizontal or almost horizontal elements which are used for those structural types. So in that vaulted arch type, all that dome is working on compression. So that gives us an ability to make its thickness the less compared to the, for example, Malian beam. So slabs and roofs in vault-attached structural type works on compression. When we consider suspended element, a suspended structural type, in this case, you can see that main load-bearing elements works on tension. And when we are talking about Malian beam, we can see the bending process here, and that means that we have tension in the uh, bottom part of the slab and compression on the upper part of the slab. When we will consider vertical elements, load-bearing elements, for example, these vertical elements which carries the dome, uh, so we will see that those elements works for the mixed situation because we can here uncentral compression, and it is mix of compression and torsion. When we're considering a suspended structural system, then here vertical element works on off-center compression, and by the way, it is also the mix of compression and tension. And in this case, when we're considering a Malian beam structural type, in this structural type, vertical elements works on the mix of center of compression and tension, and it works in the same way like over here columns work. So it works on the off-center compression. Uh, is it clear, or you need extra explanation about this part, about this table? Because this table is really important. Okay, so next, slide, so it will help you to understand the process of redistribution of interior forces in Malin beam structural type from horizontal elements to vertical elements. So if you will consider a regular slab or a beam, like it is shown in this situation, we can see that vertical loads implied applied to the horizontal elements. Then those horizontal elements redistributed on vertical elements like columns or walls, exterior and interior. And so this is the way of redistribution of interior forces, which comes from vertical loads, or in some cases horizontal loads, to horizontal and vertical load-bearing elements, which takes part in Malin beam structural type. So, and here is the finish of first level of classification. So, the highest, the topmost level of classification is called structural type. Next level of classification is called structural system. So, if a structural type it is a mix of vertical horizontal elements which works for the geometric stability and special stiffness, when we will consider a structural system, it is next level of classification which shows us the method, no, not the method, but the static schema of a structure, which shows us the way of load bearing elements works. So, for example, when we will consider a structural system Malin beam, it can be created from walls and slabs, from columns and slabs, from columns, beams, and slabs. So there is a big variety of creation of structural of Malin beam structural type. But when we will consider this structural type deeper, we have to add additional classification, which will help us to consider various structural systems which are included in structural type. So if structural type it is the mix of vertical, horizontal, and arbitrarily oriented elements, so the structural system is a static schema of structure which is independent of method of construction and the material of the bearing elements. So if their materials are not important when we're talking about structural type, in this level of classification, materials are not also not important. But if in that case, structural type, I will talk only about Malin beam, but on the example of this structural type, you can consider all other variants. So all other structural types. So if we are talking about Malin beam, it's not important for the Malin beam which is the orientation of beams. It's longwise or it's transversal or mixed situation where we have beams cross-sected at the columns. It's not important for the structural type, but when we consider structural system, it is important for us to know which way of creation of structural type in this case we are considering. So, and for structural system we have three main classifications, three main ways. So first it is framed. So one more time, all those three ways of structure, all those three structural systems are the ways of creation of one structural type. So nevertheless, is it framed? When we can see here, you can see here columns and beams. It is framed, load bearing, or in some sources it can be called wall system. But in most foreign books, you can find load bearing structure. So it is structural system with load bearing elements, with wall load bearing element. And we have also composite or mixed structural system. It is mix of columns and and load bearing walls. And all those so this created by This arrow I will show you so it can be clear clearer for you. Oh, I will show it's like this big arrow. So composite or mixed structural system, it is the combination of columns and walls. We are talking about vertical load-bearing elements. So highest level of classification of structural building structures is called structural type, and there we have considered mullion beam, vaulted arch, and suspended structural type. And when we consider lowest level of classification, we will consider only mullion beam structural type because it is most widely used. And for this type, we will have classifications of structural systems, and in this case, we have three various structural systems which are called framed, load-bearing, and composite. So this was the second level of classification. Next, third level called structural scheme. Structural scheme is next level of classification, and if structural type is the subclassification, structural system is the subclassification of structural types. So structural type, first level of classification, structural system is the second level of classification, and structural scheme is the lowest level of classification of structural of combination of structural elements in the building. And structural scheme, it is the variant of the structural systems in terms of composition and location in space of the main load-bearing structures. Why is it so necessary for us? Because it's not important for us what kind of frame system do we have when we are talking about it as a system. But there are various variants of those framed systems. For example, it can consist of longitudinally oriented beams or transverse oriented beams or crosswise arranged beams, or in some cases it can be called like a flat slab, like a beamless slab where we are not using beams at all. So all those four structural schemes are from framed structural systems. All of them are included in mullion beam system, but this level of subclassification gives us the ability to consider the ways of interaction of horizontal load-bearing elements. One more time. Uh, Mullion beam system. It is connection of all kinds of vertical, horizontal, inclinedly oriented elements or arbitrarily oriented elements. When we are talking about structural system, in that case, we are considering vertical elements. Structural system is the classification of vertical elements because it can be framed where we have columns. It can be load bearing where we have only load bearing vertical loads, and in this case, we also have composite or mixed system. It is a composition of walls and columns. But in this case, when we are talking about structural scheme for the frame structure, in this case situation, we are considering only impact of type of horizontal elements. So it's longitudinally oriented with beams with longitudinal arrangement, transverse arrangement, or crosswise arrangement of beams. And by the way, also we have one more additional variant, which is called flat slab beam frame. So flat slab beamless frame. So uh, here we will stop. So one more time. We have three levels of classification of structural elements of building, and first level is structural type. It can be used in three ways. It can be mullion beam, it can be vaulted arch, and it can be suspended. The deeper investigation of Malin beam system give us two additional classifications. First, it is called structural system, uh, framed, load bearing or wall, and composite structural system. And when we are considering the lowest level of classification, which is called structural scheme, so in this case we will consider um, variation of orientation of load-bearing elements, like for the framed structural systems, which consist of horizontal beams in various directions. They are intersected variant, and beamless flat slab. So here we have considered all three levels for the mullion beam and frame structure. Next part of our lesson will be devoted to the of our lecture will be devoted to the variants of load bearing systems, and which schemes are included in load bearing system. And one additional part of this lecture will be devoted to the mixed or composite structural system. But we will return to this in a few moments. I forgot it. So, hello, Khalil. You have joined 1 hour later. After hours the start of this lecture, I told that we will start at 8:30 according to Ukrainian time. So next hour lesson will be today at 14:40 according to Ukrainian time. So please don't be late. Right now, I will remind you main elements which we have considered with Alexandra. So right now we are considering classification of load-bearing structural elements of building. And the highest level of classification called structural type, and it is a system of buildings, vertical, horizontal, and arbitrary oriented elements, which serves to creation of the geometric stability and special stiffness. So, and there are three main structural types. It's called Mullion beam. It is called it is connection of vertical and horizontal elements, like in this case walls and slabs. And in this situation, the same idea, but the materials are more contemporary. Next, it is called vaulted arched. Yeah, vaulted arched, and the final one suspended. So three structural types, and in further investigation we have analyzed Mullion beam structural type, and in that Mullion beam structural type we have three main structural systems. And first structural system, it is framed. Second structural system called load bearing or wall system, and their combination called composite or mixed structural system. All of those structural systems can be sub-classified. So we have another third level of sub-classification, and this classification level, the next level of classification, for example, for the frame building, called beam, called structural scheme with longitudinal, transverse, crosswise arranged beams, or even a flat slab with so this is slab without beams. And this is the third, the lowest level of classification of the frame building. Next slide is devoted to the load-bearing structural system. Load-bearing structural system, as we have considering previously, consists of vertical elements uh, called walls. Yeah, and for those elements, there are three main variants of location. It is It can be with longitudinal arrangement of walls. It can be with the transverse arrangement of walls and crosswise arrangement of load-bearing walls. So this is the lowest level of classification for the load-bearing system or walled load-bearing system. And the final one variant of classification, it is the classification structural schemes for the composite structural system. For the composite, or as we told previously, can be called also mixed. Why is it mixed? It is called mixed because it is mixture of load-bearing walls and columns. In this case, we can see here walls outside, columns inside. This is a mixed or composite structural system. Here you can see another structural scheme for the mixed structural system. This system called walls inside, columns outside. And we have one more additional variant where we can combine those columns and walls and in this case we can locate walls on the lower floors of the building and columns on the upper floor, and such combinations of walls and columns can be used in non-seismic regions in the cases when we have the probability of seismic action. We have to use these or the structural system, but structural scheme. But in situation where we don't have probability of earthquake, in that case we can use this combination where we can, for example, locate columns on the lower floors, and it can be caused because of the parking on the ground floors. It can be caused because of on the first floor can be located, for example, what can be located some trade center, supermarket, or other kind of store. And on the upper floors there are only flats, so that is why it is really good to locate columns on the lower floors and walls on the upper floor. So three of these combinations, no, but it's not three. I understand that really it is not three, but it is a four variants of combination of vertical load-bearing elements, columns and walls. But nevertheless, so all of those combinations from the mixed or composite structural system uh, we can see in these four structural schemes: walls outside, columns inside; walls inside, columns outside; columns on the lower floors, walls on the upper floors, and vice versa. And all of those classifications and combination can be considered in this one slide. This will give you an ability to understand all this lecture in the simplest way. So we have three main levels of classification: structural type, structural system, and structural scheme. We have three structural types: mullion beam, vaulted arched, and suspended. And further, we have considered only mullion beam because it is most widespread. So that is why we have not considered the subclassifications and structural system for vaulted arch and suspended because it is not as common as vaulted arch as mullion beam, and that is why that classification will not be used by you in regular life. But this classification of mullion beam will be used by you as a future architect really really wide, because it will be widely used by you because it will be the most part of your practice as a future architect. So first level, it is structural type. Next level of classification, structural system. As we have considered previously, for the mullion beam, we have only three variants: framed, load-bearing, mixed, or composite structural or mixed structural system. And the lowest level of classification, called structural scheme, we will call it with longitudinal beams, with transverse beams, with crosswise beams, and without beams of flat slab. When we consider load-bearing or wall structural system, for that structural system, we have three main structural schemes. With longitudinal walls, with transverse walls, and with crossing walls. And we will consider, and if we will consider mixed structural system. So for this structural system, we have four variants of location of vertical elements. It's called structural schemes uh, uh, with outside columns and walls inside, vice versa, where we have columns outside, walls inside from the inside, and variant with the location of walls on the lower floors and columns on the upper floors, and the vice versa, walls from on the lower floors and columns on the upper floors. So that is the overall classification of all buildings that you can find in your regular life. All residential buildings are erected according to this classification of the Malin beam structural system. All trade center and other buildings are built according to this classification. Only various religious buildings were built with a vaulted arch system or combination of vaulted arch and Malin beam system. And suspended is really this structural type is really which is used really randomly because it is really expensive, and it is useful for the unique building, for the multi-story, for not for the multi-story, but for the buildings with the one floor, like stadiums, like other sport structures, or big trade structures, or concert halls, etc. are built with that suspended structural type. So that is all for this part of this lecture. Next big topic we will start today at 14:40, and I will wait for you to continue our lecture. Do you have any question? Do you need any extra explanation about this topic that we have considered right now? I will download the classroom, the concept of the lecture, but it will not include all the slides that I have shown. To see those slides, I will give a link to my YouTube channel. I'm making a record of this lecture. By the way, there you can find also the lectures from the previous years if you want to consider the whole material before I have explained it during the lecture. So you can find this material in on YouTube, and also I will send the PDF of brief lectures conspect with main topics and the main questions that we will consider during this lecture. Thank you. So see you later on 4040 and 1440, and I will explain you what is special stiffness and what is geometric stability. So thank you. Goodbye.